Now, coming to the first problem in the exercise 3, a metal sphere of radius 4.2 centimeters is melted and recast into a shape of cylinder of radius 6 centimeters. Find the height of the cylinder. Now coming to the solution. Here he has given that radius of sphere, let it be as some r, is equal to 4.2 centimeters. And he has also given the radius of cylinder, which is made from the sphere, let it be as capital, that is equal to 6 centimeters. Now he is asking us to find the height of cylinder. Let height of cylinder be h centimeters. As the metal sphere is recasted into the cylinder, here the volume of both the objects will be same. Therefore, we can equate the volume of sphere is equal to volume of cylinder, which implies the volume of sphere is 4 by 3 pi r cube, that is equal to volume of cylinder is 2 pi r square into h, which implies from this we need the value of h. So h is equal to 4 pi r cube by 2 times 3 is 6 pi r square, that is equal to 2r cube by 3r square, which is equal to 2 times r cube is 4.2 whole cube divided by 3 times 6. Here 2 goes in 6 3 times, that is equal to 4.2 whole cube by 9 times 6 is 54, that is 4.2 whole cube by 54 is 2.74. Therefore, the required height of cylinder is 2.74 centimeters. Now coming to the second question. Metallic spheres of radii 6 centimeters, 8 centimeters and 10 centimeters respectively are melted to form a single solid sphere. Find the radius of resulting sphere. Now coming to the solution. Let us assume that there are 3 spheres, each of the given radii represented as r1 is equal to 6 centimeters, r2 is equal to 8 centimeters and r3 is equal to 10 centimeters. Now he says that these 3 spheres of different radii recombine to form a single larger sphere. Let this be larger sphere radius be capital R. Let the radius of larger sphere be capital R, which is formed by recombining these 3 spheres. Now we know that when the metal is recasted to form the larger one from the small pieces, the volume of all the smaller pieces is equal to the volume of the larger sphere formed here, which implies here we have 3 spheres of different radii, radius represented by r1, r2 and r3. So your volume will be 4 pi by 3 r cube r1 cube plus 4 pi by 3 r2 cube plus 4 pi by 3 r3 cube, that will be equal to 4 by 3 pi capital R cube, which is the volume of larger sphere, which implies if we take here 4 pi by 3 common, then we get r1 cube plus r2 cube plus r3 cube is equal to 4 by 3 pi into capital R cube. Here 4 by 3 pi gets cancelled on both sides on equality. So we are left out with capital R cube is equal to r1 cube plus r2 cube plus r3 cube, which is equal to r1 cube is 6 cube plus r2 cube is 8 cube plus r3 cube is 8 cube, 10 cube. Then we get 6 cube is 216 plus 8 cube is 512 and 10 cube is 1000. That is equal to 216 plus 512 is 728 and plus 1000 is 1728. Therefore, we get Kepler is equal to cube root of 1728, which is equal to cube root of 1728 can be written as 12 cube. Therefore, the radius is equal to 12 centimeters. Now finally, the radius required is equal to 12 centimeters. Now, coming to the third question, a 20-meter deep well with diameter 7 meters is dug and the earth from digging is evenly spread out to form a platform 20 meter by 14 meter. Find the height of the platform. Now coming to the solution, here he has given that a deep well is dug with diameter 7 meters and the height as 20 meters. So here the well is dug in the form of cylinder as shown in figure with the diameter is equal to 7 meters. So we get from this radius r is equal to 7 meters, that is half of 7 meters, which is 3.5 meters, and the height of the well is h, which is equal to 20 meters. Now he says that the mud from this dug well is taken and used to form a platform in the form of cuboid. So for that cuboid, we have length, which is 22 meters, and breadth as 14 meters. Let this be as some L, let this be as some B, and he is asking us to find the height of platform. Let it be as some H. Now, as the mud taken from the dug well is used to form the cuboid, we can say that the volume of well, that is cylinder here, is equal to the volume of platform, which implies volume of cylinder is pi r square h, that is equal to the volume of platform is in the form of cuboid, so it will be LB into h. That implies pi value is 22 by 7 into r square is 3.5 into 3.5 into h value is here 20, that is equal to L value is 22 and B value is 14 into h. Here 7 goes in 3.5 0.5 times, which implies here 22 goes in 22 one time on both sides of equality. So now we left with h is equal to 3.5 into 0.5 into 20 by 14. Here 3.5 goes in 14 4 times and 4 goes in 20 5 times, that is equal to 0.5 times 5, that is equal to 2.5 meters. Therefore, the height of the platform is 2.5 meters. Now, coming to the fourth question. A well of diameter 3 meters is dug 14 meter deep. The earth is taken out of it has been spread evenly all around it in the shape of a circular ring of width 4 meters to form an embankment. Find the height of embankment. Now coming to the solution. Here he has given that earth is dug such that the diameter of the well dug is equal to 3 meters. Therefore now the radius of the well dug R will be equal to half the diameter, that is 1.5 meters, and height of the well dug is equal to 14 meters. Now he says that the earth dug has been used for building the embankment around the well, So here the volume of the earth taken from the dug well is used for the embankment. Therefore here the volume of the earth dug will be equal to the volume of the earth used for the building embankment. So let us find the volume here. Therefore the volume of earth dug for well is equal to, as it is in the form of cylinder, we know the volume of cylinder as pi r square h, which is equal to, pi value is 22 by 7 into r square is 1.5 into 1.5 into height is 14 meters. So here 7 goes in 14 two times, and here 22 times 1.5 can be written as 3 by 2 into 3 by 2 into 2. Here 2 goes into 1 time and 2 goes in 22 11 times. Therefore 11 times 9 is 99 meter cube. This is the volume of the earth dug from the well, and this will be equal to the volume of earth used for the embankment. Which is equal to 99 meter cube. Now he asked us to find us the height of the embankment. Let height of embankment be capital H. Now if we observe here, let us consider from the center. This will be the height of embankment. Now let us consider from the center. This will be the radius of the well, that is r is equal to 1.5 meters. Now the outer radius of embankment is r plus h. So let outer radius of the embankment be capital R is equal to r plus h. R plus h, here let small h be the width, that is equal to r is 1.5 plus 4 meters is the width of the embankment. Therefore 1.5 plus 4 is 5.5 meters. Now if we observe here, the embankment is also in the form of hollow cylinder. So for obtaining the volume of this, the larger cylinder volume with radius 5.5 meters must be subtracted to the smaller cylinder, here is represented with the radius small r. Therefore the volume of embankment will be equal to volume of the cylinder with the capital R radius minus volume of cylinder with the small r radius, which is equal to, if we take here pi h common, then it will be capital R square minus small r square, which is equal to pi into h value we need to find, that is height of embankment. Capital R square is 5.5 whole square minus small r square is 1.5 whole square, that is equal to pi value is 22 by 7 into capital H into, this is in the form of a square minus b square, that will be a plus b into a minus b, which is equal to 22 by 7 into h into 5.5 plus 1.5 is 7 into 5.5 minus 1.5 is 4. Here 7 goes in 7 one time. Therefore we left with 88 h meter cube. But according to problem, we got the volume of embankment as 99 meter cube. Therefore we can say 88 h meter cube will be equal to 99 meter cube, which implies h is equal to 99 by 88, which is 9 by 8 meters. Therefore we can say the height of the embankment h is equal to 9 by 8 meters is the solution. Now coming to the fifth question, a container shaped like right circular cylinder having diameter of 12 centimeters and height 15 centimeters is full of ice cream. The ice cream is to be filled into the cones of height 12 centimeters and diameter 6 centimeters having hemispherical shape on the top. Find the number of such cones which can be filled with the ice cream. Now coming to the solution, he is saying that In the right circular cylinder, there is an ice cream. So complete volume is of ice cream. The dimensions of the right circular cylinder are given as diameter is equal to 12 centimeters and height 15 centimeters. He says that this ice cream must be filled in the cones with the hemisphere on the top. And finally he is asking how many such cones can be filled with the ice cream, and he has also given the dimensions of cone as 6 centimeter diameter and the height of 12 centimeters. So now we can say that the ice cream in the complete right circular cylinder must be filled in the cones. So here the volume of the right circular cylinder will be equal to the volume of each cone into number of cones. So from that we can easily find the number of cones. So initially let us note down the right circular cylinder dimensions. For this, the diameter is equal to 12 centimeters, which implies radius is diameter by 2, that is 6 centimeters for the cylinder, and the height of the cylinder is equal to 15 centimeters, it is given. So now let us find the volume of ice cream in the cylinder. That is equal to pi r square into h, which is equal to pi value, let it be as it is, and r square is 6 square into 15, that is equal to 15 times 6 is 90 and 90 times 6 is 540. Therefore there is 540 pi centimeter cube of ice cream in the right circular cylinder. Now for the cone, the radius is given as, the diameter is given as 6 centimeters. So now radius will be equal to half the diameter, that is half times 6, which is 3 centimeters, and the height of the each cone is given as 12 centimeters. Now as height of complete cone is 12 centimeters with the hemisphere placed on it, so here for the cone the radius is given as 3 centimeters and the height is given as 12 centimeters. So now if you consider the cone ice cream here, it has a cone separately and hemisphere placed on it. So complete volume of the ice cream is obtained by adding the volume of cone and volume of the hemisphere. So here we have the complete height of ice cream as 12 centimeters. Therefore we get height of cone alone as 12 centimeters minus, we have to eliminate this radius of the hemisphere, that is 12 centimeters minus 3 centimeters, that is equal to 9 centimeters. Now the volume of cone with ice cream with the hemisphere on the top is equal to volume of cone alone plus volume of hemisphere, that is equal to volume of cone is pi by 3 r square h, that is radius and height of cone, and for the hemisphere the volume is 2 pi by 3 r cube, which is equal to, here we can take pi by 3 r square common into h plus 2r, that is equal to pi by 3 into, here the radius is 3, so r square is 3 square into h is 9 plus 2 times r is 2 into 3, which is equal to pi by 3 into 3 square is 9 into 9 plus 2 times 3 is 9 plus 6, that is 15. So here 3 goes in 9 3 times, therefore 15 times 3 is 45 pi centimeter cube. Now let us assume that there are n ice creams made using the ice cream from right circular cylinder. Therefore, the volume of ice cream used for cones will be equal to n times the volume of each of the cone ice cream, that is 45 pi centimeter cube. Now, as the ice cream in the cylinder is used for making the cone ice creams, here we can say the volume of ice cream used for cones, that is n times 45 pi centimeter cube, will be equal to the volume of ice cream in the cylinder, that is 540 pi. That implies n is equal to 540 pi by 45 pi. Here pi in the numerator and denominator will be cancelled, and 45 goes in 540 12 times. Therefore, the number of cone ice creams made is equal to 12. That's the solution. Now coming to the question number 6. How many silver coins 1.75 centimeters in diameter and the thickness 2 centimeters must be melted to form a cuboid of dimensions 5.5 centimeter by 10 centimeter by 3.5 centimeters? Now coming to the solutions. Here there are some silver coins which are of diameter 1.57 centimeters, 1.75 centimeters and the thickness of 2 mm. So he is asking how many such coins are required to melt and form a cuboid of certain dimensions, that are 5.5 centimeter by 10 centimeter by 3.5 centimeter. So here initially he gave the dimensions of coin, that is diameter is equal to 1.75 centimeters, which implies radius is half of diameter, that is 1.75 by 2 centimeter. Now he is also given the thickness. So here the coin, if we consider, it is in the form of right circular cylinder with the very less height. Therefore here instead of thickness we can take the height of coin, that is h is equal to 2 mm, which can be converted to centimeters, gives 0.2 centimeters, as 1 mm is equal to 1/10 of centimeter. So here let us find the volume of coin, that is pi r square h, which is 22 by 7 into 1.75 by 2 whole square into 0.2. That can be simplified as 4.4 into 1.75 whole square by 7 into 2 square is 4. This is centimeter cube. Let it be as it is. So here he says that certain number of coins are melted to form this cuboid. So let us also find the volume of cuboid. As the dimensions are directly given, the volume of cuboid is length into breadth into height, that is 5.5 into 10 into 3.5 centimeters cube. Now as certain number of coins are melted and formed this cuboid, let us assume that n coins are melted to form the cuboid. So here the volume of all coins melted will be equal to the volume of cuboid. Therefore the volume of coins melted, which is equal to n times volume of each of coin, that is, let this be as V1, n into V1. This must be equated to the volume of cuboid, that is n times V1 is 4.4 times 1.75 whole square divided by 7 into 4 is equal to the volume of cuboid is 5.5 into 10 into 3.5. From this we need the value of n. Therefore n will be equal to 5.5 into 10 into 3.5 into 7 times 4 divided by 4.4 into 1.75 into 1.75. So here 4 goes in 4.4 1.1 times, and 1.15 goes in 5.5 5 times, and 1.75 here goes in 3.5 2 times, and 1.75 goes in 7 4 times. That is equal to, here the number of coins are used are 5 times 10 is 50, and 50 times 2 is 100, and 100 times 4 is 400. Therefore the number of coins used to make the cuboid is 400. That's the solution. Now coming to the 7th question, a cylindrical bucket 32 cm high and with the radius of base as 18 cm is filled with the sand. This bucket is emptied on the ground and a conical heap of sand is formed. If the height of the conical heap is 24 cm, find the radius and the slant height of the heap. So now coming to the solution. Here he has given that in a cylindrical bucket, it is completely filled with the sand of the height 32 centimeters and the radius 18 centimeters. And he says that this bucket is completely emptied on the ground so that it formed a conical heap of certain height, that is 24 centimeters. And he is asking us to find the radius and slant height of the conical heap. So now, as the sand discharged from the bucket is forming the conical heap here, the volume of sand discharged to form the conical heap from the cylinder will be same. So here the volume of cylinder will be equal to the volume of cone. Therefore let us note down the cylinder dimensions. That is cylindrical bucket. Radius small r is given by 32. Radius small r is given by 18 centimeters, and the height of the cylinder h is given by 32 centimeters. Now the volume of sand in the bucket is equal to pi r square h, which is equal to pi, let it be as it is, and r square h is here 18 square into 32 centimeter cube. Let this be as it is. Now for the cone, here for the conical heap formed, the height is given as 24 centimeters and he is asking us to find the radius. Let the radius be capital R. Now volume of heap is equal to, as it is for cone, we can say 1 by 3 pi r square h, that is equal to 1/3 of pi r square capital R square into h is 24 centimeters. Therefore here, as volume of sand from the bucket is discharged to form the cone, the volume of cylinder will be equal to the volume of heap formed, that is pi into 18 square into 32 is equal to 1/3 of pi into r square into 24. Here 3 goes in 24 8 times, and pi on the both sides of equality will get cancelled. Now we get r square is equal to 18 square into 32 by 8. Here 8 goes in 32 4 times. So we remained with r square is equal to 18 square into 4, which is 18 square into 4 can be written as 2 square. That implies capital R radius is equal to square root of 18 square into 2 square, that is 18 into 2, that is equal to 36 centimeters. Therefore the radius of heap is equal to 36 centimeter. Now we have the radius of the heap and also the height of the heap h, that is equal to 24 centimeters. Now what we need to find is the height of the heap. Now what we need to find is the slant height of the heap. Let slant height of heap is equal to some L. As it is in the form of cone, we know that slant height L is equal to r square plus h square under square root, that is equal to square root of r square here is 36 square plus height is 24 square, that is equal to square root of, from these two we can take 4 square as common, then it will be 9 square plus 24 square is, from this we took the 4 square common, so it will be 6 square, that is equal to square root of 4 square into, from these two again we can take 3 square common, then it will be 3 square plus 2 square, that is equal to 4 times 3 is taken out from the root, that is 12. Square root of 3 square plus 4 square is 9 plus 4, that is 13. Therefore the slant height of heap is equal to 12 root 13 centimeters. Now coming to the 8th question. Water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. How much area will it irrigate in 30 minutes if 8 centimeters of standing water is needed? Now coming to the solution. Here it says that a canal is 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. So he is asking how much area will it irrigate in 30 minutes if 8 centimeters of standing water is needed. Now coming to the solution. For the canal, let us note down the dimensions, that is width of the canal is equal to 6 meters, depth of the canal is given by 1.5 meters, let this be as some B and this as H. Now he says that water is flowing with a speed of 10 km per hour. So here in the lengthwise there is a change in velocity. Therefore here we can write speed with which water is flowing is equal to 10 kmph, kilometer per hour, that is equal to, as he is asking the result for the 30 minutes, let us convert this into the flow of length in 30 minutes, that is 10 into kilometers can be changed to meters by multiplying it with 1000 divided by 1 hour is equal to 60 minutes. So here 60 minutes, let us write it as it is, which is equal to 10,000 meters by 60 minutes can be written as 2 times 30 minutes, which is equal to, here 2 goes in 10,000, 5,000 times. Therefore we get the speed is equal to 5,000 meter per 30 minutes. Now as the speed we obtained in the meters per minute, 30 minutes, we can find out the volume of water that flows in 30 minutes, which is equal to, width is here 6 meters into depth is here 1.5 meters, and there is a lengthwise change in the speed. Therefore here the length will be equal to 5,000 meters, that is equal to 6 times 1.5 times 5,000 is 45,000 meter cube, and he is asking that there is a need for 8 centimeters of standing water. So here the height of the water required to stand, H, is equal to 8 centimeters. Converting this into meters, we get 8 by 100 meters, Now volume that flows in 30 minutes will be equal to area irrigated into the height of standing water required. Therefore, the area of irrigated land in 30 minutes is equal to volume of water flows for 30 minutes divided by height h, which is equal to 45,000 by 8 by 100. That is equal to 45,000 times 100 divided by 8. Here 8 goes in 45,000, 5,625 times into 100, that is equal to 562500 meter square of land. If we convert this into hectares, we know that 1 hectare is equal to 10,000 meter square. Here 5,62,500 meter square land will be equal to 56.25 hectares. Therefore, the area of land irrigated with the 30 minutes flow of canal is 56.25 hectares. That is the solution. Now coming to the 9th question. A farmer connects a pipe of internal diameter 20 centimeters from a canal into the cylindrical tank in a field, which is 10 meters in diameter and 2 meters deep. If water flows through a pipe at the rate of 3 km per hour, in how much time the tank will be filled? Now coming to the solution. So here he is saying that a farmer is connecting a pipe of certain dimensions to the tank in her field, whose dimensions are given. So here he is asking us to find in how much time the tank will be filled if water flow rate through the pipe is 3 km per hour. So in order to find that, we can say that if the water is flowing through the pipe that is filling the cylinder, the volume rate of flow in the pipe will be equal to the volume at which the cylinder is filled. So here let us find the volume of cylindrical tank initially. So for the tank, the dimensions are given as diameter is equal to 10 meters, which implies radius is half the diameter, that is half times 10, which is 5 meters. Let it be as r. And now the height or the depth of the cylindrical tank is given as 2 meters. So the volume of cylindrical tank filled in certain time t is equal to pi into r square h, that is pi, let it be as it is, and r square is 5 square into h is 2. 5 square times 2 is 25 times 2, that is 50 pi meter. Here he says that water flow through the pipe is 3 km per hour. So rate of water flow in pipe is equal to 3 km per hour. Let us convert this into meter per minute. That will be equal to 3000 by 60 meter per minute, which is 50 meter per minute. So now consider for the pipe, the dimensions are diameter is equal to 20 centimeters. Further conversion of radius gives 20 by 2, that is 10 centimeters, which is 0.1 meter. As we know that 1 meter is equal to 100 centimeters. Therefore here the volume rate of flow in cylinder, the volume rate flow in pipe will be equal to pi r square into the rate at which water is flowing in the pipe, that is 50, which is equal to pi into r square is 0.1 whole square here into 50. Now the time required is equal to volume of the cylinder at time t, that is 50 pi centimeter cube divided by 50 pi meter cube, this is meter cube, divided by, this is also in the meter cube, that is pi into 0.1 whole square into 50. Here 50 pi and 50 pi in the numerator and denominator will be cancelled. This is meter cube and this is also in meter cube. Meter cube will be also cancelled. The time required to fill the tank will be equal to 1 by 0.1 whole square, which is equal to 1 by 0.1 can be written as 1 by 10 whole square, that is 100 minutes. Therefore, the total time required to fill tank is equal to 100 minutes. That is the solution.